Hello! Yes, and welcome to our Objective 3.2 notes. Objective 3.2 says I can solve like-base exponential equations. And that's what we're going to do today. So when solving like-base equations, the name itself is a little misleading in that you'd think, oh, the bases are the same, I'm solving them. Well, you're going to make the bases the same. So that's the first step. Rewrite the equation so that both sides of the equations have a common base. And then once both sides of the equation have a common base, all you need to do is set the exponents equal to each other and solve. So let me show you what I mean. Looking at letter A, both of these bases are already 3. Therefore, all I need to do is set the exponents equal to each other. I'll say 3v plus 1 equals 3. I subtract 1 from both sides. I get 3v equals 2, divide by 3, and I find that v equals 2/3. Easy. All right? When we have the common base, set them equal to each other. Now, look at letter B. One of our bases is 36, the other is 216. So now's the time where we need to think, okay, 36, 216, how can I rewrite those with common bases? And the answer is simple. It'd be 6 squared, that's 36, to the 3x, equals 6 to the third, right? 6 to the third is 216. Now they have common bases. Think about what we do for our power of a power. We'd multiply, so we'd say 6x equals 3. Those are our two exponents now. Divide by 6, and we'd find x to equal 1/2. Excellent. Okay. Looking at C, this is a good one. I really like this one because think about, well, 6 is my base here, but this is 1. I can't write 1 in any way so that it becomes a base of 6. So I have to be thinking, well, 6 to the what power gives me 1? Oh, anything to the 0 power gives me 1, right? So I can say 6 to the 1 minus 3a equals 6 to the 0. And now I have a common base. So I can say 1 minus 3a equals 0. I can add 3a to both sides, divide by 3, and I find a to equal 1/3. All right. Hopefully we're building some confidence. Let's do a few more together. Let's look at letter D. 243. 243 is a large number. We need to be thinking about, okay, what base am I going to use? Now, our other value having a base of 27 gives us a hint. Okay, so 27 is 3 to the third. So we can say this is 3 to the third to the negative 3b here. Now, 243 is 3 to the fifth. So this would be 3 to the fifth to the negative 3b plus 1. So we're going to multiply power of a power. So I have 5 times negative 3b plus 1 equals 3 times negative 3b. Right, and I'm getting that from my exponents here. That's what I'm multiplying. So I'd have negative 15b plus 5 equals negative 9b. I can add 15b to both sides. So I have 6b, divide by 6, and I'd find b to equal 5/6. Beautiful. All right. Ooh, a good fraction. We haven't talked about those yet. So I see here I have 1 over 5. Well, I know that, remember, that means I must have a negative exponent. 5 to the negative first is 1 over 5. Now 625, we should know that 625 is 5 to the fourth. So I would have 5 to the fourth to the negative 2x plus 3 equals 5 to the negative first. So that would mean 4 times negative 2x plus 3 must equal negative 1. So distribute here, I have negative 8x plus 12 equals negative 1. Subtract 12, so negative 8x equals negative 13. Divide by negative 8, and we'd find x to equal 13 over 8. Fantastic. All right, lastly, F. 1 over 64 to the 2 minus 2x equals 16. Well, there's actually a couple bases that work here. It could be 2. This is 2 to the 4th, 2 to the 6th, or it could be 4. And that's going to be the one I use here. This would be 4 to the negative 3rd, 1 over 64. to the 2 minus 2x equals 4 squared, 16. So then I take my exponents. Negative 3 times the quantity 2 minus 2x equals 2. So I have negative 6 plus 6x equals 2. Add 6 to both sides, so I'd have 6x equals 8, divide by 6, and I find that x equals 4/3. And there we go. And that is what the process looks like to solve like bases. If you're feeling confident with these, go ahead and get started with your practice problems. If you want to look at some sample problems, go ahead and check out that video as well. This is Mr. Carter signing off. I'll see you next time.